Hey guys, welcome to our video of today. So we're going to start with example 3 in your section 2.3 notes. So question 3, or example 3, I'm sorry. Given the graph below, so here's your graph, okay? I'm going to erase some marks because I've written some marks earlier, okay, there you go. So you're provided with a graph, a function. There are some questions, A to F, so we're going to answer each one, okay? At what numbers, if any, does F has a local maximum? Remember, maximum is the highest point. Absolute max is the highest of the highest, okay? So local max is mean the second to the highest or the third highest and so on and so on. So check this out. This looks like a W. I won't have any absolute max, okay? Because these arrows, they go up forever. If they go up forever, I'm never going to have the highest of the highest. So this one is no absolute max. It doesn't ask in this question, but we might as well get to know it, okay? But I do have a hump here, okay? So this is the second highest that I can see, or in this case, because remember, I don't have the highest. This is higher, this is higher, this is higher, and if the two arrows on the sides, going to keep on going forever. So you're never going to have one highest point, period. But this one is going to be my second highest, so we're going to call this the local maximum, okay? So at what numbers? It's asking for x value, okay? So at x equals to, looks like when x is positive 1. At x equals a positive 1 when I have a local max, okay? Then it says, what are the local maxima? Local maxima is plural for maximum, just in case there are more than one. In this case, we don't have more than one local maximum, so we're just going to have one maximum. So at is really talking about the y value. I'm sorry, x at what numbers, really talking about the x value. What are they is really talking about the y value. The local maximum is positive 2, okay? So when x is 1, the output is 2, so it's asking for the y value. So local maximum is local max is, and you give me the y value, which is 2, okay? At is really aiming for x, okay? What are they? Meaning y. So question C is going to say, at what numbers does F have a local minimum? Again, here's the word at, okay? So your answer should be the x location of this point. So local minimum. So let's talk about it. Local absolute minimum is the lowest of the lowest, okay? So see this right here? This is the lowest point you're going to see. So this is, in theory, an absolute minimum, okay? Absolute min. Now, there's a second point here that's also the second to the lowest. Not the lowest of the lowest, but here it is, right? So this is called the local min, okay? But here's the thing. An absolute min can also be a local min, okay? So this point, I can either call it absolute minimum or local minimum. But this point, I can only call it local minimum. I cannot call a local minimum an absolute min. So just to recap this really quickly, an absolute min can always be a local min, but a local min can never be an absolute min. So it says here, what are the local minima? I should have two y values for this problem, not always. It says here, at what numbers? I should have two x values. So here we go. The first x value is going to be at negative 1. Okay, so at means x equals negative 1. And the second x value is 1, 2, 3, so at 3 as well. Okay. What are they? In this case, I have two y values. So the first y value is when x is negative 1, y is 1. So local min is 1, and the other one is when x is 3, y is 0 and 0. Okay? So local min is, and these two are the y values of the location of local min. Okay? List the intervals on which f is increasing. Okay? List the interval on which f is decreasing. So now I want interval notation. Okay? So list the interval. So here we go. Increasing, I mean, if I'm going to the right, my y value should increase. Okay? Decreasing means if I'm going to the right, my y value should decrease. So let's start. Because I do have an arrow here, an arrow means I'm going to go up and out forever. So we are starting from negative infinity. From negative infinity, I'm going to stop at this thing called the local min. And usually that's where the breakpoint is. In calculus, we're going to get further into what these are for. But right now, we're going to say local min, local max, okay? And another local min. So from negative infinity, we're going to stop at the first local minimum. And if I'm going to the right, look at this. Y value is getting less and less and less. So that's really decreasing, okay? So let's write increase over here and decrease over here. Okay, so it's decreasing from negative infinity all the way to, this is my x value of -1. Then I'm going to keep going to the right. Can you see this right here? From here to here. Look at my y value. It's getting higher. So that's an increase. Okay, so from -1 to +1, I'm increasing. Okay, and I'm going to keep on going. So here's where I stop at 1 over here. I'm going to keep going to the right and taking a little break here at another local minimum. Look, my y value is getting less and less and less, so that's decreasing. So from 1 to 3. Okay. Then I'm going to keep going to the right. If I keep going to the right forever, it's called positive infinity over here. And remember, this one's going up and out. So imagine it keeps on going forever. So I'm going to, at some point, go towards infinity. So from 3 on to towards infinity, y value is increasing. So this is going to be increasing. Then the last piece, F, is that find the domain and range. Because we do have arrows that's going to go up and out, the domain is going to be all real numbers. So the domain, all real numbers, old school. Then the range, okay. The range is not going to be all real numbered because there's no arrows going down. But we do have the smallest y value. The smallest y value is starting at 0. See this right here? So that's where we are going to start in our interval notation. And because we do have an arrow, actually 2 arrows going up and out. So this is going to go towards positive infinity on the y-axis. So the range, it's just from positive, I'm sorry, not positive, from 0 inclusive, which is square bracket, going all the way up. Okay. We're going to go down to example 4. Let's see how long 4 is. Okay, so 4 is stopping at E. Okay, so 4, given the graph below again, so you have another graph here, determine A, the absolute maximum and absolute minimum. Okay, again, now absolute is the highest of the highest. So the highest max is this one. There's nothing higher than that. So that is your absolute max. I'm going to write A max. Okay, so determine absolute max. This one, it doesn't tell you at or what, so we can write it as a point. That's the nice thing. So this point is actually 1, 2, positive 2, up 2. So positive 2, 2. It's just a point. This is not an interval. Okay. Then absolute min, A min. Okay. A min is, this is the lowest point. There's nothing lower. So this is your lowest point. So it's going to be -1, -2, -3. And this one goes about -3, comma, -2. So -3, -2. Then it said, hey, are there any local maxima and local minima that we should look at? So L max, let's see. Are there other high point that's not the highest of the highest? Sure, okay. So let's look. Looks like we have this point, right? Okay. So that looks like that could be your local max. So local max, let's see what that point is. It's going to be -1, +1. So -1, +1. And then, do you see anything else? Remember, local max is also the absolute max. So we can answer 2, 2 as well. Even though this is an absolute, it can also be named local. Okay. Then, we are going to look at this right here. Okay. This is an obvious, that's your local min. So L min. Okay, so I'm going to name this. This is 0, comma, negative 1. 0, negative 1. But remember, a local min, it's also, okay, I'm sorry, an absolute min is also a local min. So I can, in theory, even write this down. Negative 3, negative 2. So this is absolute min, but it's also local min. This is just local min. It cannot be called absolute min. Okay? Oops, it's really bright. Make it less bright. There you go. And I should use a pen. Okay. Now this right here, this dot, okay, is, this dot, believe it or not, it's also a local min. Okay? So we have 3 dots for local min. So let's just 1, 2, 3, 4. So 4, comma, y value 0. So your local min has 3 answers. Okay? Your L max, local max, has 2 dots. And usually absolute is only 1 answer at all times. Okay? C, list the intervals on which f is increasing. So it looks like f is increasing from 1, 2, 3. So negative 3. So this is a negative 3 value. So we're going to go negative 3 all the way to, let's see where my local min or max is. Looks like that's a local max. That's where I'm going to stop. So x of that is 1. So negative 3 to 1. Or also increasing. Okay, so it went from negative 3 to 1. And that's increasing. This is from negative, sorry, this is negative 1. Okay. So this is from negative 1 to 0. So this is a 0 for x. That's decreasing. So negative 1 to 0 is decreasing. Then from 0 all the way to another local max here. Okay, so this is 0. That's increasing, and that's 1 and 2. That's 2. So 0 to 2 is your local, is your increasing interval, because that's an absolute max. Then we're going from here to here, that's decreasing. So 2 to 1, 2, 3, 4. This is a 4 for x. So 2 to 4 is decreasing. Okay. So keep that in mind. Your textbook uses, remember in class I mentioned parentheses, okay, the entire time. Other books use it, okay, I just want to let you know, other books using interval, closed interval, so I'm kind of using, I'm not going to mark it wrong and just use open parentheses the entire time. Okay, find the domain and range. So the domain, we do have open, closed dots on both ends, so the domain is just going to be from negative 3 all the way to 4. So close, negative 3 all the way to 4. Your range is going to be, the lowest y value is this right here, which leads me to believe that's negative 1, negative 2. So this is a negative 2 y value, okay, all the way. So that's going to be a positive 2 value right there. So last question, it says, hey, is this even? Is it odd? Is it neither? So it's not symmetrical about the y-axis. Okay, it's not symmetrical through the origin. So I'm going to say this is neither. If I'm going too fast, can you please pause and then just try to go back? All right, as I am waiting for you to finish copying, I'm going to tell you a little toddler joke. Why did the melon jump into the lake? So why did the melon jump into the lake? It wanted to be a watermelon. Ha ha ha. All right. Let's go on to one more example. Okay. And we're going to do example 5, and this is going to be the end of our video today. Example 5 is asking you to use a graphing calculator. So let me go take one out. Okay. So here's my calculator. And I want you to read this question very cautiously. Use a graphing calculator to graph f of x equals 2x to the third minus 2x plus 1. For, check this out, for x is only between negative 2 and 2. And then I would like for you to approximate where f has any local maxima or local minima. Okay? So this is so important. This is So important, even though it looks like it's just any random thing, just like the rest of the question. But it's so important because this is what your window will be. Okay? It's giving you a window, or it's giving you a domain for this problem. Okay? So I'm going to go y equals, clear out what I had before from notes, and I'm going to punch in 2x. I have to the third power, so let me zoom in. Okay? So I'm going to do a caret, and do a little caret right there. Okay? Do to the third power, so which is 3. Then I want to minus 3x, and I want to do plus 1. Okay. So that's what I have in my y equals. Now, I don't want you to go to zoom and do the standard zoom. You have to go to window. Your x min and x max can only be what? It doesn't want everything. It doesn't want from negative 10 to 10. It just wants from negative 2 to 2. So did I tell you how important this is? Like super important, okay? Once you have entered in an x min for negative 2, x max for 2, then I want you to hit zoom. Because we did enter in the x min and x max, it's not standard fit, is zoom fit, okay? It's not the standard zoom. So go to zoom fit, which is 0, and hit enter. All right. See that right there? So if I'm sketching this out, okay, I can only have 2 values over here and 2 values over here. That's it. Nothing else. You got it? And I'm just sketching it out. I'm not sure what these values are yet. So from negative 2 is somewhere down here. And notice how it's not inclusive. So if I'm sketching this out, this should be like a hole of some kind, okay? And then it looks like it's it doesn't run through the origin. So I'm kind of down here a little bit. And at some point, slightly, I'm not sure where it is, but it's like down here somewhere. And then up here at 2, remember this is 2 for x, this is negative 2. Also an open circle. Because it's not including the 2 endpoint. That's why these are, and it doesn't go on forever. It only wants from negative 2 to 2, period. All right. So now it says, hey, I want you to use the calculator to approximate if it has any local maxima. Sure it does. Here's the local maxima. Okay, local max. And here is the absolute max. We're going to find both. Let's do absolute max first, because I'm just going to do from left to right. So here we go. Second, trace, go to maximum. And it's going to ask you 3 questions. The first one is left bound. Remember, absolute max is somewhere here. So left bound means it's on the left-hand side of there. So here's, doesn't matter how far. Okay, go wherever you want as long as it's on the left-hand side. So here's, hit enter. Then notice how the second question said right bound. Remember, local maximum is somewhere here. Right bound is somewhere to the right. So make sure you go far enough to where it says right. Okay, enter. And yes, I want you to guess because that's what it wants. Okay, so here we go. It says local maximum is, and I'm going to round to 2 decimal places. Okay, so local max is. Sorry, my light just turned off. I have to get up and dance, otherwise the light's just not gonna. There you go. It just turned back on. Local max is. Let me make this not as bright. Okay, it's. I'm gonna give you as an order paired. So negative 0.71. Say to round this correctly, look at the third digit, then round this up. So it says here approximate where f has any local maximum. So local maximum is negative 0.71, comma. Okay, so the y value is 2.41. So 2.41. So round it to 2 decimal places, okay? Now, and then we also want to find the local min. I'm sorry, I wrote local max for both, didn't I, on here? This is supposed to be local min. Okay. All right, so local min. Well, local min is really right here. Okay, so I'm going to do second trace, second trace. We're going to go down to minimum. Hit enter. And remember, I want to trace this. So left bound is really somewhere on the left-hand side of this. So that looks like a good left location. And right bound is going to be somewhere over here. Okay? As long as you're on the right-hand side. Okay, enter. And it said, hey, do you want me to guess? I do want you to guess. And this is where I'm going to ask you to write down your own answer. Okay, where is your local min? Round to 2 decimal places for me, please. And write it in. So if you're not listening, that means you're not writing it in, and I won't stamp your homework. So please just write it in. And this is the end of a video. So tomorrow when I stamp this, make sure this is all filled in. Have a wonderful day, and I will see you in class.